Alright, ladies and gentlemen, this is 1-9 notes on rotations. Some more notes. Objectives: you'll be able to rotate a figure about the origin and rotate a figure that does not have a center at the origin. So, in this triangle, it says triangle ABC is shown in the XY coordinate plane, as you see up here in quadrant 2. And the directions down here, they say the triangle will be rotated 360 degrees counterclockwise around the point -4, -5 to create the triangle A prime, B prime, and C prime. Indicate whether each of the listed features of the image will or will not be the same as the corresponding feature in the original triangle by selecting the appropriate box in the table below that we have here. So we're going to take this triangle, we're going to rotate it 360 degrees. We're going to rotate it around the point -4, -5. So -4, -5 is -1, 2, 3, 4. And then down 5. 1, 2, 3, 4, 5. So that red point is the center of rotation. Now, if we rotate this figure around the point 360 degrees, that means C gets rotated all the way around 360 degrees. I just did it clockwise, but here's counterclockwise. Rotate it around. It actually lands right back on the original coordinate. So C and C prime are the same coordinate. This also applies with B. B gets rotated around that coordinate and lands right back where it started. So B and B prime are the same coordinate. Same story with A. A gets rotated around 360 degrees counterclockwise and becomes A prime. And like those three dots, you have your green triangle. So just to recap real quick, it all rotates around. So will coordinates of A and A prime be the same, or will it not be the same? Well, it will be the same because it rotated 360 degrees. Same story with B and B prime. C and C prime. It all landed on itself because it's a 360 degree spin. Now the perimeter. The perimeter, it does not change in size from the original. So the perimeter of ABC and ABC, A prime, B prime, and C prime will also stay the same. The area is the same amount of boxes horizontally, vertically, and on a diagonal. So it's the same area, length times width. The measure of angle B, well, angle B is a right angle and it stays a right angle. So the angle of B stays the same. And the slope AC, this guy right here, that also stays the same. So in this problem, it just is a triangle on top of itself with all the angles and all the sides being the same, and the location of A, B, and C. And A, B, A prime, B prime, and C prime are the same. Let's look at another one. So in this case, the center of rotation is at the coordinate 4, 3 down here. So it's 4, 1, 2, 3, 4, and then 3 up. 1, 2, 3. So the center of rotation is on B itself, that coordinate. So we're going to rotate around that B. To do this, we have to rotate 90 degrees counterclockwise. That means, starting from where this A is, where the green dot is on A, it's going to go 90 degrees. So it's good. A is going to land somewhere around here. So it's going from straight up to straight left. So due north to due west. So A is 1, 2, 3, 4, 5, 6 points up. A 90 degree rotation counterclockwise goes from north to west. So we went 6 up. So now we're going to go 6 to the left. 1, 2, 3, 4, 5, 6. That's where our new A prime is. Now C was east of B. So it's 1, 2, 3, 4, 5 to the right. So 5 boxes east. So if we do a rotation of 90 degrees, we go east to north. So this is now 1, 2, 3, 4, 5. we connect them up, because B just stays the same, stays right on top of itself, because that is the rotation, or the point of rotation, center of rotation. And now we have our A prime over here, and our C prime is up here, that green dot. Now the size of the triangle when rotated stays the same. So when we're filling in these dots, the same questions over and over, make them a little bit bigger too. The area of ABC and ABC prime stays the same. The measure of angle B, when it gets rotated, stays the same angle. The perimeter stays the same because it's the same size. Now the coordinates though, the coordinates of B stay the same. However, the coordinates A and A prime are different. So we mark those as different. And the coordinates of C and C prime, those are different, so we mark that as those coordinates will not be the same. Now the slope, well, AC's slope is this line right there in purple. A prime and C prime, that slope, clearly you can see that it's different. So the slope of A prime, C prime, and the slope of AC, they are different. So they're not going to be the same. So we're going to mark that. That's your answer for that number 2. Let's do another one. So we have our same type of problem set up. Our directions are down here. The triangle will be rotated 90 degrees counterclockwise around the coordinate, or the point, -4, -1. So -4, -1, that's 1, 2, 3, 4. -1's right there. We got to do a 90 degrees counterclockwise rotation. So we know clockwise is like this. So counterclockwise is this way. So that means where this coordinate A prime is going to be somewhere around here. Now notice, from our center of rotation, A is south and west. So a 90 degrees counterclockwise rotation of south is east. Going west, a 90 degree rotation counterclockwise is then going south. So what we're going to do, this is south and then west. We're going to do east then south. That's how we're going to find our A prime. So right there is the coordinate of A prime. Southwest, 1, 1, will be east, south, 1, 1. Now B is located 1, 2, 3, 4, 5, 6, 7, 8, 9 south. So that means we got to go 9 east. 1, 2, 3, 4, 5, 6, 7, 8, 9 east. And then it went 1 west, so we got to go 1 south. And that's our location for B prime. Now C, to find C prime, we got to count it out. So from this red dot, we go 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 south once again. So that means 9 east, just like B prime was. Then we went 1, 2, 3, 4, 5, 6 to the left, or 6 west from that red dot. So a 90 degrees counterclockwise rotation of west will be south. So we got to go 1, 2, 3, 4, 5, 6 coordinates down from B prime. 1, 2, 3, 4, 5, 6. And that's where our C prime is going to be. We connect up our triangle, and we successfully rotated that blue triangle into the green triangle, a 90 degrees counterclockwise rotation, about the point -4, -1. Now let's look at this triangle and analyze it a little bit, or these two triangles. We got to compare and contrast. So our options here, is the coordinates of A and A prime the same exact coordinate? No. We could see that the coordinate has moved, so they're not the same. So we fill in that dot. B and B prime, well, they're not the same, so we fill in that dot. C and C prime, they're not the same, so we fill in that dot. The perimeter has not changed. It's the same amount of boxes all around. So if we count out between A and A prime and B prime, it'll be the same exact amount of boxes from A to B. If we count out how many boxes up and down A prime to C prime is, it will be the same boxes up and down, or left and right, from A to C. So the perimeter stays the same. The area also stays the same. By definition of area, length times width, divided by 2 for each triangle. And the measure of angle B. Well, angle B is the 90 degrees angle here, and it is also here. So they're both the same. So angle B stays the same. Now the slope, AC goes like this, and you see A prime, C prime goes like that. So clearly they're different slopes. It's not the same angle. So they're not going to be the same. Alright, let's do another one. Our center of rotation is telling us down here -5, -2. So -5, 1, 2, 3, 4, 5, down 2. We got right there. That's our center of rotation. Pretty far away. Our goal is to rotate this triangle, ABC, 270 degrees in a counterclockwise rotation, meaning our coordinates around this circle are going to go around this way, counterclockwise, 270 degrees. That's the same thing as doing 90 degrees clockwise. So 90 degrees clockwise. Alright, so 270 degrees counterclockwise. Let's take this coordinate A. How far away is A from this center of rotation? Well, it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 to the right, or 10 east, and 1 south. Now when we do a 270 degrees counterclockwise rotation, east becomes south, and then south becomes west. So 10 east is now 10 south. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 south, and they went 1 south before the original, so we got to go 1 west. So that's our location of A prime. Now, B is 1, 2, 3, 4, 5, 6 south in our original, so we go 6 west from A prime to find our B prime. 1, 2, 3, 4, 5, 6. There's our B prime. Now it seems to me like our picture is going to go off the graph here. And that it will. Because